let's just cue things up with why are we even talking about metal 3D printing? Why is this so important? We talked about 3D printing several times here on Webinar Wednesday. We interviewed a high school teacher and a technical college instructor about how they're using 3D printing in their classrooms. We have talked with some engineers and technicians who are manufacturing 3D printing technology, and we've gotten really into depth about what that technology looks like. We've even talked about some schools who are implementing CNC machining alongside 3D printing, so kind of that additive subtractive manufacturing all at once. So I'm excited today because we are actually getting to talk firsthand to a university student about how she's been using metal 3D printing as part of her research for her engineering degree. So this is totally kind of a new twist on the same topic, and I'm excited to get to her story. Now, let's take a look though first at the 3D printing market. I know this study here that I'm going to show you is just a few years old, but if we look at kind of the past few years and when 3D printing sort of started taking hold and increasing in the market, and the study that came out just at the beginning of 2019 just predicted an explosion of use cases for 3D printing in industry in the coming years. I think this goes all the way to the mid-20s. And a different study predicted that the compound annual growth rate, specifically for metal 3D printing, from 2019 to 2027 was going to be 32.4%. I mean, this is just exploding everywhere. And the reason is this: we're seeing just a massive increase in the different technologies that are being innovated as different ways to 3D print. I'm not gonna spend a ton of time on these, but these are just different methodologies for how we can print in different materials. Today, we're focusing on that powder bed fusion, so we're gonna hear a little bit more about that in a little bit, but tons of different technologies. The materials that we can print, I mean, the list just grows every year. I mean, we often think of plastics, and especially in education, oftentimes that's where we stop, but there's so much more that we can print. When we're talking about ceramics, nylon, we're getting really heavily into the reinforcement materials and this is often with when you're extruding your main material, whether that be a nylon or a plastic, but at the same time, you're extruding a reinforcement materials, and we can reinforce with carbon fiber, with Kevlar, with fiberglass. And just the variety of metals that we can print in today is just incredible. All kinds of tool steels, titanium, stainless steel, cobalt, nickel, copper, bronze, the list goes on and on. And then the industries that are using 3D printing just continue to grow. This is just a general list of some of those, but each of these industries are finding increased use cases for 3D printing. And so when we kind of look at this, all of these lists and look at it together and we say, why should we be teaching 3D printing in school? It's because the applications for industry are endless. And when those students are going to get into industry and their employer is trying to find different ways to implement the technology, if that student has understood the design and material science behind 3D printing, they're going to be invaluable to any employer in almost any industry. So just as a really quick case study of what this looks like in industry today, let's take Cummins, for example. That's a name everybody knows and is familiar with. And we actually interviewed Cummins Senior Vice President of Manufacturing and Supply Chain, Peter Anderson, a few months ago on the Tech Ed podcast. And we asked Peter what are some of the Industry 4.0 technologies he's using in their manufacturing operation today to increase productivity. And one of the things he spent quite a bit of time talking about was their use of additive manufacturing. I love this quote. Peter said, "Additive manufacturing allows you to design in an unconstrained fashion." And what engineer wouldn't love to take away constraints? So Peter went on to list some of the specific ways they're using additive today, but the ones I want to focus on are these the metal use cases. So casting molds. They have over 20 SKUs that they're actually shipping off end use parts to their customers that are printed in metal. And then really fascinating, he kind of gave us a little preview without too many details, but they're investing in some really high tech metal 3D printing technology that is going to allow them to produce high volume automotive components. And that's kind of been one of the constraints from industrial employers investing in 3D printing is that it's often tends to be low volume or focusing on, like it says earlier in this list, functional prototypes. But companies like Cummins are looking at high volume production now with 3D printing. That's how incredible the technology has grown. So what does this mean for education? In many cases, education adopted 3D printing before industry. If you look at fab labs, maker spaces, STEM spaces, all of these schools already have 3D printers. So now the question is, what are we teaching with those 3D printers? 5-10 years ago, we were maybe printing these figurines and these toys. Students would find an STL file on the internet. And it's great to inspire students to be creative and to create things and to watch the technology in action. But now it's time to take our teaching to the next level. And we need to focus on the material science, the design engineering, the application-based design. So going from something like figurines to something like this, just as a quick example, this is a high school student who designed and printed a coin sorter. And so he's got to think about, okay, the tolerances for making sure the different sized coins all fit in their slots and putting them in the right order, making sure each of those slots is stackable. So when you shake it, there's no movement. It's a simple concept, but he's actually learning a lot more going through that process. And so today I'm really excited because we are talking to somebody in higher education who's using a much, much more advanced technology in metal 3D printing for some of the same type of things. Hannah Luben is a first semester mechanical engineering master's student at Penn State University. She received her mechanical engineering bachelor's degree from Penn State in their 2+2 program, where she spent the first 2 years at the Scranton campus and finished her schooling at University Park in May 2021, so just a few months ago. She's jumping right into that master's degree, and it's awesome. In her spare time, Hannah enjoys knitting and spending time with her cat, Peach, who's pictured there. Hannah, thank you so much for joining us today on Webinar Wednesday.
Absolutely. Thank you so much for having me.
So I'm really excited to let you share your story and your experience with our audience today. But first, I just have to say, I love the representation of seeing a female engineer. Tell our audience what inspired you to get into a pathway of engineering.
Sure. So my mom actually inspired me. She is a civil engineer with her own firm, and that was a huge inspiration growing up. So when I got to school and was trying to figure out what I wanted to do, I thought, okay, why not try engineering?
And what inspired you to do mechanical engineering in particular?
It's such a broad field. You can do so much with it. My first passion was actually aerospace, but that's a very narrow field to get into. So with mechanical, I thought you can also do aerospace, but look where I ended up working in additive. So there's so much you can do with it.
I love it. I love that you took that more broader approach, because then you just have so much more options when you pursue your future and then decide where you want to go. That's an awesome story. I love to see that generational inspiration coming from your mom. I love that. So like many engineering students, Penn State students have to complete a capstone project as part of the degree requirements. So what did for you at Penn State, what does a capstone project entail?
Sure. So every student who graduates with an engineering degree has to do some sort of project. It's typically one semester, and students will be paired with other students, some in the same major, some in different majors. And they'll work in a collaborative team, typically with another company, usually in the same area, to work on some type of project to get some hands-on experience. And for me, it was the most valuable part of my school.
Absolutely. We talk all the time about just getting that real world experience is just, there's nothing that beats it. You can have all the classroom experience in the world, but yeah, I love that real world experience. So your project all centered around metal 3D printing. What was the overarching objective that you were taking on?
Sure. So we were asked to optimize parameters for printing a particular type of stainless steel.
And what company did you work with for that?
Xact Metal. They're a local 3D printing company over in Innovation Park. It's maybe 5 minutes away from State College. So
Awesome. And for those who don't know, Xact Metal is one of our partners here at Lab Midwest. And Hannah, could you explain for those of our attendees who aren't familiar with the layout of Penn State and what exactly is Innovation Park?
oh, it's it's a lot of office buildings where a ton of amazing startup companies like Xact Metal can rent rooms and office spaces alongside more spaces that can accommodate some equipment that they have, like larger pieces of machining equipment. So it's home to so many amazing different companies that are doing all of these groundbreaking technologies.
Yeah, absolutely. I mean, Innovation Park, right? And let me go back. Sorry. It's great because it's right there in this hub where there's all these students who are doing research and they have access to just the top talent in the area to recruit from. So as you experienced firsthand, we'll get to that in a little bit, but just a great layout there of Penn State and that partnership with Innovation Park. And one more question before we move on, I'm just curious to know when who all was involved in your group that did this capstone project together. You mentioned that sometimes there's students from different engineering disciplines.
Yeah, so I was one of 6 students. I believe we were evenly divided. Obviously, I was mechanical engineering. So I think there were 3 of us in mechanical engineering and 3 students in material sciences and engineering, since this was a very material-based project.
Yeah, absolutely. And speaking of, let's kind of get a little bit deeper into the details. Before we do, for all of our attendees, I know we have some people who are very technically experienced and would love to hear all of the details that Hannah has to share. I know some may not be so technically advanced, and if she goes over your head, don't worry. We'd love to share more about this with you. And if she starts to intrigue you a little bit, I'm sure she'd love to have a deeper conversation about what the project entails. But you mentioned, Hannah, that your project involved optimizing parameters for printing in a certain kind of metal. For those who might not be as familiar with what that means, can you help us understand what 3D printing parameters are and how they work?
Absolutely. So when you're ready to print something in plastic, the printer already knows what material you're going to use, and it says, okay, I know how to print this. Print parameters go into that, but they're preset in the machine with plastics, typically. So with metals, since they're different materials that you're working with, you have to optimize these parameters for each individual material. So we looked at 17.4 stainless steel, and we said, okay, what are the laser speed that we have to run the machine at and the hatch spacing? And the way that powder bed works is it takes a laser and it fuses metal powder in layers. So the speed at which that laser moves is very important for optimizing these parameters. And the hatch spacing is when you take, if you have a circle that you're filling in, you're going to take a zigzagging pattern to fill that in completely. Exaggerated, obviously. They're very small zigzags. But the distance between those consecutive passes of the laser is called the hatch spacing. So those 2 items we took and we looked at different ways to optimize them to get the highest density that we possibly could in our printed parts.
Well, yeah, I think to your credit, you did an amazing job explaining something that's technical to in a non-technical way. So thank you for that. Now, what are some of what are the tests that you perform to optimize those parameters?
Sure. So since there were those 2 main factors that we looked at, we set up a matrix where we would have multiple values for each of the 2 parameters. So say we wanted to test 3 different speeds and 3 different hatch spacings. We would set up a 3x3 matrix with a grid of 9 cubes, density cubes. They're kind of shaped like this, where they have a little point at the bottom that's easy to just break off. And then we would test their densities just using an Archimedes scale to see where the highest density trend was directed.
Excellent. And I'm going to call this out again for our non-technical attendees, but what is an Archimedes scale?
Sure. So the Archimedes scale is a principle, and there's several machines that can accomplish it, but it's a way to measure density of a part. You measure it in air, and then you measure it in a liquid. We used ethanol so that it would evaporate quickly between different passes, because we measured each piece multiple times to get an accurate reading.
Excellent. Thank you for explaining that. So tell us, after going through this process for a semester with your team of 6, what were the results that you were able to achieve?
We had 99.8% density in 17.4 stainless steel. Our goal was 99.5% density, which is the industry standard for other comparable companies who do the same type of printing with metal.
So excellent. You were able to surpass the industry standard, that's excellent. And 99.8% density is just incredible when we think about, the difference between machining something from a raw material versus 3D printing something. I think the density is a factor that plays heavily into that. And to be able to achieve 99.8% density, 3D printing is it's incredible. It allows you to do so much with the design and the structure of whatever you're printing. So congratulations to your group on completing that, and congratulations for graduating from Penn State in May. After graduation, then you were able to actually go an internship at Xact Metal. So tell us how that transition happens and what was your role over the summer?
Absolutely. So we were looking for someone, well, Xact Metal was looking for someone to run this printer and do similar material development over the summer, similar to what we did in the capstone project. So they offered to all 6 of us, asked who would be willing to stay, and Peach and I decided to stay. She was part of the conversation. So we worked with so many more different materials doing that same process, but it went much faster since I already knew kind of what I was doing, and I helped to not to use optimize again, but to optimize that procedure for figuring out what the best parameters are for these different materials.
Absolutely. And what were some of the other materials you were able to work on over the summer?
Sure. I worked on a 400 series steel, 15.5, and 4130 over the summer.
Absolutely. And out of curiosity, are they very specific to the parameters that you found were the optimal parameters? Were they very specific to each type of metal? Are they very different from each other?
It depends on the material. So, for example, 316 stainless steel is a metal that Xact Metal prints very confidently. 420 stainless steel is very similar to it. So in starting the 420 parameter development process, I took the 316 parameters and kind of centered my matrix around that to test that out.
Got it. Excellent. And so now you are, as we mentioned, in your master's degree. So lots of wonderful things going on for Hannah Luben. Now we mentioned that, I don't know if we mentioned this actually, but you didn't have any 3D printing experience prior to starting your capstone project. So first of all, I before we get to this, tell our audience what it was like for you to have your first experience in 3D printing.
Well, it was beyond cool. You've seen some of the parts that we've been printing. It was just so amazing to put all of these parameters into the computer, to design a geometry, and then to physically hold it in your hand was just beyond amazing. But like you said, yeah, I really had no experience 3D printing before this, and to jump right into powder bed fusion metal printing was super cool. I'm actually in an additive manufacturing class right now, which is helping me to learn the basics. But we did our own research going into the project when I took the class in the spring. But picking up actually running the printers was a snap. Even when I had to run everything on my own in the summer during my internship, it only took a week or two to actually pick up learning these machines. They're so simple, so easy to use.
And that's what we love to hear, just the ease of use. So you went from no experience to completing your capstone project to, like you said, doing a master's level. course in additive. So I'm sure that in that time frame, you've learned about all different types of 3D printing methods. For our audience, I know I shot through a few of those at the beginning of our presentation, but can you help our audience understand, what are maybe the main types of printing methods? And then as a follow-up to that, when you're printing in metal, what's the advantage of using a powder bed fusion method?
Absolutely. So when you think of 3D printing, typically most people think of extrusion, which is where you take a wire filament or a plastic filament, and you take a nozzle and you deposit that in your layers. And it's typically a pretty large filament relatively. But in powder bed fusion, you have this insane level of accuracy. Remember the hatch spacing that I talked about, the distance between those consecutive passes of the laser, it's in micrometers. So it's so small, and it's so amazing to get this level of intricacy in powder bed fusion.
Absolutely. So, well, we're excited about your future. And I know our audience has loved to see the transformation that you've shared with us from, no additive to capstone project, and just to see you grow in your mechanical engineering pathway. What are your future plans?
So primarily dinner, but then in the next couple of years, I'd like to finish my master's, obviously. I'm considering a minor in additive, which I wouldn't have even thought of if not for this project and working with Xact Metal. So we'll see what happens after that. If I do get that minor, I wouldn't be opposed to pursuing a future in additive, but we'll see.
I love it. To all of our educators on with us today, if that isn't enough of a reason for you to put some additive in your program, I don't know what it is. What is? Now, in just a second, we are going to let our audience ask Hannah questions. So you can use that Q&A in your Zoom control panel audience to submit your questions to Hannah. While I give you the time to type those in, I want to tell everybody about just an incredible event we have coming up. Because metal 3D printing in particular is so new to education, I think there's a lot of educators who are still testing and trying to figure out what the best technology is, what's the best way to teach this in my course, what are the best programs that can use this technology. A lot of questions out there, and a lot of maybe inexperience with even getting hands-on that kind of technology. So what we have done is we have brought together some of the experts in education, in industry, and in technology for a half-day event here at our tech center just north of Milwaukee for a best practices in metal 3D printing for education seminar. So we'll have educators talk about how they're implementing metal 3D printing in their programs. We will hear from students like Hannah who have done it and can share their experience. We'll hear from employers about how they're using it in industry. And you'll get to be hands-on with the technology. You'll get to see how it works. You'll get to look into the machine. You'll get to see how it pulls data and the parameters and how you can change things, and start thinking about how we can get this into our schools and start teaching it in our programs. So like Hannah said, she had material science students and mechanical engineering students. I mean, if you're structural, electrical, biomedical engineering, no matter what engineering focus you're in, additive manufacturing fits. It's being used in every industry today. So let's get it in our schools. Just a plug for that event coming up. I'll make sure to put it in the follow-up email, the information on that if you're interested in attending. All right, at this point, we will pass things over to our audience Q&A time, and we'll let our audience plug their questions in, and I will pose them to Hannah. So the first one, Hannah, I just have to share this with you. Rock on, Hannah. Well spoken. You made engineering very accessible for this CPA, and that is from your aunt. So love to see that support there. How can you tell us, is it safe? That's a big question we get a lot.
Yeah, absolutely. I felt very safe. There's, of course, PPE that you have to wear. Whenever I was working with the powder, we would close the door, so it was in a separate room. I would wear rubber gloves and a full ventilator hood with oxygen circling through. So definitely safe.
Absolutely. And to our attendees, everybody working in industry is used to wearing PPE anyways. It's just another use of that practice, and there isn't any kind of large construction that has to be done to the building in order to, with the ventilation and everything. So it's just a few pieces of PPE, and it's extremely safe. We have another audience comment here. This is a great example of the value of internships, work-based learning, and as such play into education. Hannah, what can you say to other students to encourage them to keep their minds open, because you never know where it will lead you?
So I looked at this in choosing my capstone project. They gave us a list of all of these different potential projects. And I looked at this one and thought, that looks hard. I hope I don't get picked for that one. And then I did, and it was the best experience. So in all truth, go for it. It's so hard to get yourself motivated for it, but I hope that my story will help inspire and encourage other students to really commit and do the same, because I wouldn't have changed a thing. This was so valuable, like I said.
Love it. Thank you so much, Hannah. I love that. And I'll just address one more question from our audience. I'll address this myself. Nick, thank you for posing your question. From a cost standpoint, what would it take for a school to get into additive using metals? Thank you for that question. Xact Metal was designed to be accessible. I mean, that was honestly the first thing that they had in mind when they were manufacturing and designing their printer, was to be accessible for education specifically. That kind of plays into the whole thing with them being in Innovation Park right next to Penn State. And this whole idea that, education has limited budgets, limited space. They wanted to make sure that the students had their hands on metal 3D printing technology as early as possible. We would love to talk more details about what exactly that looks like. I don't want this to be a sales pitch or anything, so feel free to email me, or I'll respond to the follow-up email, and we can chat more on that. Hannah, I just want to say thank you so much for joining us today and sharing your thoughts with our audience.
Thank you so much for having me. It's been an absolute pleasure.
Absolutely. To everybody else who joined us today, thank you for your time. As always, we are here every Wednesday afternoon at 2 Central, 3 o'clock Eastern. We will see you back next week.